Okay, I think we can kick it off. Okay, so we have Thomas here today. Like, I'm super happy he joined because he's been doing some amazing work at Meta. I think you were literally part of some of the most impactful and interesting projects over the past year or so, including LLaMA 2, Bloom, Toolformer, Galactica, CodeLLaMA, Nougat. Like, so many exciting works. I think I played with most of those, and I think I've read all of those papers. So like, really happy to have you here. You can basically kick it off now.
All right. Do you see it?
Just a second. Yeah, we can see
Yes.
it. Large language models, past,
Nice.
present, and future. Nice.
Yeah. So, I mean, the talk is about like 30 minutes of LLM starting from the past, the present, which was basically LLaMA 2 and LHF, and some of my perspective about the future of large language models. I think you wanted me to start also by a bit of...
Yeah, sure. So like because you mostly have like technical stuff here on the slide, I think most people will be interested to hear a bit more about your story. I think you made this one podcast recently, but I'm not sure you talked about your background.
Yeah.
So like I guess most people would like to end up in your position, and maybe you can give us like a speed run. What does it take for somebody to end up as a LLaMA 2 lead or LLaMA 3 and lead, whatever?
So let me maybe tell you about my background a bit. Don't hesitate to ask follow-up questions for more details on whatever now or after the talk. But basically, I joined Meta 1.5 years ago on the large language model team. At the time, it was Papers with Code. You know, this website that report all the numbers, the benchmarks automatically, etc. And so I joined this team working on Galactica, this large language model for science. The goal was basically to go to Papers with Code, organizing science at another scale, leveraging large language models. And I was the first research scientist of the team. Well, from a scientific perspective, it went well. And I think Galactica was a really good paper and model, one of the first of its kind for Meta. After that, I worked on Toolformer that made a bit of noise. And at this time, actually, it's interesting because we had such a pivot at Meta as a company to work for and through ChatGPT-like models, investing now massively to this kind of technology. So we had a shift, and we started working on basically. So some of my friends and colleagues built LLaMA 1, which was only a pre-trained model. And so the question was, in February of this year, how to move from those pre-trained models to chat aligned with human preference, LHF. And that's what I will talk in this presentation. So for the story, I was working in parallel of Galactica to a Galactica Instruct, like almost a chat Galactica, that a researcher could work on overleaf to basically predict citations, insert it, modify LaTeX tables, edit, change the style in a more academic way, all these things. We had a partnership with Overleaf, and well, after the Galactica backsplash, we didn't release it. But so we were already working on that, and then we kind of did a long sprint from February to July for LLaMA 2. But so before joining Meta, I was doing my PhD in natural language generation, reinforcement learning, and also part of a startup, Recital. TAL in French means traitement automatique du langage, which is basically natural language generation in French. And before that, I was in finance, so that's an old story. If you ask me also about how to end there, and from finance to the PhD, I think it was at the time of AlphaGo, I decided to understand better what is machine learning, artificial intelligence, and I wanted to dig more. I did first a small degree like of 6 months, and then I decided to move full-time to like a PhD. I think also it's very relevant for a PhD to have worked a few years in industry, like in finance on my case, before, because most of the PhD students start after their master and they never worked in industry. That can help. Yeah, so that's basically my background.
That's awesome. By the way, like I did notice a pattern that a lot of finance people transition to machine learning. Like back at DeepMind, I had a lot of colleagues who used to work like in finance, and then they started working as engineers or researchers. Also, like David Hard, the Hardmaro guy on Twitter, he was also previously at Goldman Sachs.
Yeah.
So finance, and then went to machine learning. So there seems to be like, I guess both attract people who like think in an abstract manner and like who are attracted to numbers, and also, not gonna lie, like there is money involved, like in both areas, like is significant, and so like quite makes sense. I wanted to ask you about the PhD. Like, what was you said it's NLP, but like more like specifically, what did you focus on during your PhD?
I had mainly like two pillars of focus, which are related to one another. So it was all about natural language generation. And so one pillar was reinforcement learning. It was really like ChatGPT, RLHF before RLHF, with like kind of training a reward model and fine-tuning the large language model on that. But in my case, the reward model, I didn't have the money of OpenAI to annotate. And so in my case, the reward model was a classifier trying to distinguish between a human output and a model output. So you could formulate it also as a GAN for language. And all the other aspect was about evaluation of those models. I developed a family of metrics based on like question answering, question generation, where like the main intuition was, so there's an open research problem about evaluating those models. Like in the case of summarization, abstractive summarization, when you have a newspaper or a research paper and your model generates a summary, how can you evaluate it? Like the main metrics like bleu, rouge, are based on n-grams. The thing is you have a lot of ways to formulate. So the surface of possible response is very high. And those metrics are very poorly correlated with human judgment. So the main intuition of the metrics I developed was, what if you generate with a model, and this is a simple task, questions. So it takes the generated summary, generate a lot of questions based on that, and the answer. This is like a trivial task for models. Then ask the question with respect to the source article, and then compare the two answers. If the information present in the summary is factual and corresponds to the original text, then it's factual summary and it's good, and you can measure the amount of information that was present there. If the answers diverge, then there's some hallucinations. And then you could use this metrics to train also language model to be more factual with reinforcement learning in the same spirit.
That's crazy. You started your PhD when? That was like back in 2017, 16 or a little earlier?
No, actually quite late, in 19. So basically, I think the first ever conference I went was in Bruxelles, EMNLP, the week BERT was released.
Nice. The reason I asked is because like everything you mentioned like looks like very prescient of you to go into those fields, because literally everything you said, NLG, RL, evals, that's like 3 top topics right now in machine learning, right? Whereas most people who go the PhD route will eventually end up like in some niche field that's going to become irrelevant in 2 years' time or something.
Yeah.
So like it seems you were on that main branch, and like curious whether you had any insights before, or you just kind of were connected with the right people or that love transformers, and so you kind of ended up doing what you said you've done.
So first, I didn't have any insights, and I have to say I was quite lucky. That's something to acknowledge. I think also I ended in a very good team in Paris. You know, it's the same team that had, as a PhD student, a lot of people like Guillaume Lample, which now founded Mistral, Hugo Touron, who was the first author also of LLaMA 1 and now LLaMA 2, working with me now. There's a lot of great people, and it was one of the best team in France to do a PhD. And I ended up there, honestly, because some of my friends told me to go there. I had no clue it was a good team at the time. So a lot of luck, I will say.
Great. And one more question, I think you can kick it off. Sorry for taking a bit longer here, but I think it's going to be super relevant to people. Like, what do you think is the thing with Paris and machine learning? Like we saw, of course, Mistral some months ago, And then I think a couple of weeks ago, maybe a week ago, there was this new 300 million announcement for this new research AI lab in Paris, K something, I forgot that. Yeah, Q-Tai.
Yeah, which means sphere in Japanese. I mean, you have that, and you had Poolside, and there's so many other startups. Very cool. And in fact,
Hugging Face, right? They are from.
And Hugging Face, I was at their office this afternoon for a paper we co-released today. So yeah, and LLaMA 1 or LLaMA 2 were from Paris office. In fact, so. I had this. Let me take a few more minutes to discuss that, because it's related also to what you said about finance. I think in finance, you had a lot of very strong, finance desks, had a lot of French people, because France is very good at training for math, coding, like all those schools are very good for engineering schools. Thing is, for finance, you had a lot of people around the world that moved from Paris, and you found the French in New York, in Hong Kong, in London. And I think Meta is quite responsible for having created a cluster of AI people in Paris, so that it created an opportunity for strong researchers in AI to not move to the USA or England, but actually stay in Paris. And if you check, so Mistral, but so all those people, but also like this non-profit, most of them are from Meta, in fact. And I think this is mainly due to thanks to Meta and Yann LeCun that set this big office of research in Paris, and having setting an opportunity for French researchers to stay here, which now with the growing ecosystem is delivering some nice things.
100%. And I see Jan is very bullish on like France, of course, like he's a patriot, I guess, and like very, very interesting dynamics. A lot of smart people. And yeah, definitely like in contrast, for example, with DeepMind, I think the office for DeepMind is super small in Paris. The whole focus is on London. But like thanks to Google and Meta, literally the European ecosystem was started, which is weird and interesting.
Yeah, absolutely.
Anyhow. Cool. I think you can now kick it off. This was a longer intro, but awesome.
Sure. Not hesitate to ask. I don't see the Hangout or the Discord chat, but if there's some question, I can answer them on the fly. Just ping me.
Sounds good. People will raise hand, and then I'll be curating.
Cool. So, all right. Well, the first slide is about I think we are living a crazy moment for AI, no doubt. And I want to just acknowledge that from ChatGPT is only 1 year ago, I think this week or next week. And at what moment in the history we had a technology that spread that fast? So it's born in the Silicon Valley. André Carpati, who everyone knows him, I guess, here, write 80% of his code with this kind of technology already. But Microsoft already also adapted ChatGPT to ChatGPT processed on trained on administrative documents in India with some specific dialect written, so that every Indian at the far end of India could access and ask questions to the chatbot in their own dialect. So I think this is we are living a moment unique in the history. And when I say the science fiction is because I love his definition of AI from Nick Bostrom, the philosopher, saying when it works, it's not AI anymore. And that has been true in the history of computer science and AI, with the game of chess, it's a bit like magic. When you have a magic trick, well, people are so impressed, it feels magic, but as soon as you know the trick, it's not magic anymore. And I think when I'm saying we are now living in a science fiction moment, is because we know how to make work, to make ChatGPT works, and this works. And yet it remains a bit of science fiction still for people. So I'll start with the brief history of the large language models. First, what is a large language model? So I think it's two things. The weights, so the famous transformer architecture, and the data, the training data and then how do we digest the data into the weights with the next token prediction loss, which is basically completing the sentence from the left to the right. And it's quite beautiful how just this simple loss is enabling to have some emergence of capabilities around a large board of fields, from like benchmarks in math, in science, in programming. It works for everything. One intuition I like to give from Ilya Suksev's talk I was inspired from recently is about this concept of compression memorization, where those models are really good to compress data. And so if I give you 1,000 of examples of calculus, like 1 + 1 = 2, 2 + 2 = 4, how do you compress that? Well, you can memorize. And if you memorize everything, the thing is, I can always find a new example that you will never see during training. And because you will not generalize if you only memorize, you will fail. But then the most beautiful compression of information in this case will be to internalize the algorithm behind the data, which is basically calculus. And then you don't have something that more compressed than that. And you can generalize to any new calculus and predict the next token after SQL. I feel that that's a good intuition of what happens with next token prediction and transformers. So just this method at scale works extremely well, as we know. And for GPT-3, they tested like a lot of different recipe of what you scale. There's two things you can scale: the data or the weights. And batch size and serial steps are part of the data factor. Model size is about the weights. And from their analysis during GPT-3, they found out that the main impact is about the size of the model. So it's better to put more flops compute on the model size rather than the data. They had GPT-3, which was like a window into the future. The model developed some capabilities extraordinary. Yet, so this is like just on Trivia QA, some performance showing improvement even above the fine-tuned model that was SOTA at the time, just by scaling the number of parameters. Same recipe, same algorithm, same data, just more weights, and that works. I think that's beautiful. But yet, we had our friend from DeepMind. I think at the time of the paper, OpenAI already knew, but that basically redo the scaling laws, and they found out that the methodology of OpenAI had a mistake because OpenAI forgot to adapt the scheduler of during the training, and so they kind of over-penalize the smaller models that could have been trained longer, adapting the scheduler better. And so few months before this paper, they trained a huge model as well, Gopher, 280 billion parameters. What is really cool in this paper is that they did a lot of empirical experiments at small scale, below 10 billion parameters, from which they extrapolate some empirical scaling laws, saying that you have to, data actually matters a lot, more than we thought with GPT-3. And so every time you double the model size, you should double the data, training data. And according to that, we can, like for a given flop amount, set the right balance between the model size and the number of steps and training data. And they said, okay, for Gopher, we have this amount of flops. Let's do the same experiments, but with now the empirical law we have. And so they train a model 4 times smaller, Chinchilla, 70 billion parameters, on much more data, 4 times more. And the model largely outperformed Gopher. Yet, I think this is kind of what I call the chinchilla trap that some people followed, in the sense that, you know, this is like how, given a specific amount of flops, get the highest number for my training model. For like a research paper when you want the best ball numbers. The thing is, in practice, you want your model to be used by a lot of people. And so this wasn't taking into account the inference cost. Where my colleagues at Meta with LLaMA, I think it's about like rethinking compute optimal. What we observe in this training loss is that it keeps decreasing the loss with respect to more and more tokens. And so, sure, the thing is you can train for longer your models, much longer than before. Maybe for the same amount of flops, it would have been better to do something else if you want the best bond number in a paper. But the thing is, at inference time, with respect to the two axes we have, the training data and the model weights, well, bigger models, it impacts the inference. With bigger models, you have a higher inference cost. But training longer on more data doesn't have any impact on the inference cost. And so maybe it's for more compute optimal at inference time, it's better to overtrain on more tokens and smaller models. And so LLaMA was also released even in a non-commercial way, and that was followed by a lot of people already like updating it for like running on phones, Raspberry, etc.
A quick question here. I mean, more observation. If you can go back a slide and one more. Yeah, there. Like, I mean, it's fairly obvious even when you look at these curves. Like, look at the blue curve.
Yeah.
Just extrapolate more tokens. You can preserve the same like 7B, and then you're gonna end up with the same loss. So like, it's fairly like all of these things are fairly obvious. Like, it boils down to having conviction. Like, the biggest thing that happened was like OpenAI scaling up to GPT-3. After that, people were like, okay, scale matters. And then you have a couple of dimensions of scale, right? We have like the model size. Okay, sure, let's push that. And then, okay, well, is the balance with data right? And then, oh, it's not right. And then let's scale the data. Like, things are so, like, it's interesting how not difficult the ideas were, but like how big of engineering feat this was, more than research, which is like surprising maybe. Not to Rich Sutton, but to us.
Yeah, no, I fully agree. Engineering is a big part with respect to scaling, and the fact that OpenAI was able to scale that at the time they did with the cluster and GPUs they had at the time is something fantastic.
Crazy. I remember OPT paper. Sorry for a small tangent. Like the OPT paper and the logs, and that was not the only thing. Like, I think that was your first bigger LLM, and like it's just crazy how they've done it back in 2019, basically with GPT-3.
Yeah.
So like it was an amazing engineering feat.
Absolutely. No, 100%. Which leads us to, so, well, following LLaMA, you had a lot of follow-up. I think there's now with LLaMA 2 more than 8,000 follow-ups, and there's all a zoo family with the alpaca and vicuna and all the possible models, derivatives. And so people wanted for us to release the weights in a commercial way without a gate access. I'm sure you all remember that time. And so we worked on LLaMA 2. That indeed I led until July when we released it. So for the pre-training, it's just incremental gains, you know, more tokens, obviously it helps, twice bigger context length, people wanted that, that's good. But from the research novelty, it's much more about the chat aspects. Let me tell you a bit about that research. So first you have supervised fine-tuning. This is a way to annotate the data, which is very standard in NLP, in language generation. So you want a chat GPT model? Well, people used to ask some prompts and expect some answers. So we want the annotators to write this kind of data. So the annotator has to write a prompt and the response that he will expect from the model. And then we will train in a supervised manner of this. Well, kudos to the annotators because it requires a high quality of annotation. You don't take any random annotators and a lot of creativity. But then there's a second method that was popularized by like RLHF style reinforcement learning with human preference. And so here the idea is the annotator still writes the prompt, but then we sample from the model 2 answers. And in that case, you know, it's 10 times less expensive for the annotator because he doesn't have to write the answer. He just have to say which one he prefers. And based on this preference, we can train what we call a reward model. It's just a classification model that given a prompt and an answer, give a scalar score. So we can say, we prefer this one or this one. And this is what looks our reward model score during LLaMA 2. You can see that bigger model, better scores, but also like more and more data was even always better. Maybe something about evaluation, because we discussed that at the beginning. Evaluation is an open resource question for language generation, in particular for chat models, because they are by intrinsically like multitask, massive multitask models. The good news with reward models is because it's a binary classification, well, the evaluation is extraordinarily trivial. And so given a recipe, which is your training algorithm, which whatever it is, DPO nowadays, PPO, whatever. If you improve the performance of a reward model, which is something you can measure very easily, you are guaranteed to improve the performance of your chat model by construction. Here is, so with rejection sampling algorithm, where the intuition with respect to reinforcement learning human feedback is very easy to understand. So imagine you have a prompt and you can sample 100 examples. So now we score all of them with the reward model. If you take just one, well, you have like the median of the rewards. Now, if you grow the number of samples, well, the median should not change. But the likelihood that one of the trajectory, one of the answers sampled by the model, obtain a higher reward model result, it improves with the number of samples you have. That's very trivial. And so the potential gain between the max of the rewards and the median of the rewards grows with the number of samples. And if you fine-tune your model on the output that had obtained the max according to your rewards, instead of just the median, now you have a potential gain of that performance with respect to your reward model. And this is reinforcement learning with human feedback with a very simple algorithm. And we apply that.
Stop you here for a sec. Can you go back 2 slides before that one? Okay, so on the x-axis, can you maybe clarify a bit more this particular plot?
So you have the model size, 7B, 13B, 70B of LLaMA models, trained on our reward model data that we collected that way. And here is, so in the Y coordinate, we have like the reward model performance on a test set. So basically we collected like thousands of examples like that. And given a prompt and answer, we use our reward model to score it. Then we score also with respect to this one. We know that the human labelized this one as higher. So if our reward model gives a higher score for this one, it's accurate. Otherwise, it's not accurate. And so this is the score between 0 and 1. 50% means random, basically. 1 means a perfect alignment with what human will have said. This is GPT-4 and Open Assistance zero-shot performance. So just as a comparison, because we didn't train the models, GPT-4 Open Assistant, on our data distribution, well, we are doing that for our model. So it's expected to have a better score. And it's impressive GPT-4 zero-shot performance.
Nice. And the x-axis, I guess, is the confusing bit for me. Let me see.
Okay. And so,
helpfulness.
So the X is more data. And the way we represented it here is during every week of the project, we received a new batch of data from our annotators. Note that the number of data kind of grows with the latest week of the end of the project. And so this is just that. So here we had like, I don't remember, but maybe 2,000 reward model data. Here we received 5,000 more. Here, 6,000 more. At the end of the project, we are even receiving like 100,000 of annotation per week. Mm-hmm. And so this is what we have. And every time we train a reward on all the data.
Why is it called meta helpfulness? I guess that's the confusing bit.
So in the paper, we had like some category. So for training the reward model, we use Open Assistant data we use that they collected. We use some open source models, data sets for reward modeling, like Anthropic had one, WebGPT had one. And what we called meta helpfulness is so all the data collected for this project, LLaMA, meta, with respect to helpfulness, because we had two categories we collected for the reward model, the helpfulness and the safety data.
Okay,
it helps
yeah,
you?
it helps. And we have more questions maybe from the chat. We can take it. Akash, you want to ask it yourself or I can read it?
We can take it now. You can tell me because I'm near like with the presentation, I cannot see it.
Okay, sounds good. So it would be good to hear about the research platform for these models, more precisely HPO, experiment tracking, open source tools, and what non-trivial things did we do to increase the model development velocity, basically the infrastructure around model training and evaluation. If you can maybe clarify a bit more there.
So about the infrastructure we had to build for the whole project, right?
Yeah, for I guess LLaMA 1 and 2.
I mean, we have some training algorithm internally, but like the one that now are on Hugging Face based on LLaMA are like kind of similarish, like nothing magic. I think the complexity, and we had to move very fast, like in 14 weeks, like basically 4 months, to create an API with the annotators to sample from our models, to get the data, to retrain them every Monday, the reward model, then apply rejection sampling, then PPO. We don't have a specific framework. In fact, we just build that from scratch for the project.
Got it. So, and how does FairSec and XFormers play into this whole picture? I think that I know FairSec was used for No Language Left Behind, for example. I know because I'm open sourcing right now. But like in general, can you tell me a bit about the landscape? And I also know you have like public and internal versions, which is I guess obvious. But like if you can, as much as you can share publicly.
Yeah, I mean, there's nothing like, to be honest, like a really secret. Just like I don't think we open source the codes, but it's based on XFormer and not Metasec or FairSec. And I mean, it's just some code we build from scratch internally, but we could have used, if they exist now, like maybe we would have used Hugging Face codes. I don't know, like, you know.
Mm-hmm. How much of an effort was like building a code base? Like I saw that Mistral folks built it up like from the from scratch part bothers me because like there are just so many edge cases when you're building these, right? Like there is just so much complexity. And so like what does from scratch even mean?
So first thing is, think that for the training part, we benefited largely from LLaMA 1 infrastructure and trainings because pre-training and fine-tuning can be seen the same way. We had to build on top of that like PPO algorithms, rejection sampling. But rejection sampling is just sampling and retraining on the selected one by the reward model. So very trivial. Training of the reward model is not very hard. PPO, we had to build that from scratch, but that's not a big deal. For fine-tuning, you had like all the API and support with respect to the annotators. That was also a lot of infra work to do. So we benefited from LLaMA 1 overall. A lot of different things to deal with and to build. We had to work a lot, but nothing like fancy and secretly hard to build. The sum of it is very hard and complex, but nothing individually.
Mm-hmm. Building the RLHF pipeline, did you consider using some of the existing open source solutions? Like we recently had Luis from Carper AI. He worked on the, is it TRLX? I'm gonna butcher the name. But like I know it's used by a lot of companies, just forked internally and stuff. Like, how do you decide whether we're gonna start from scratch and maybe solve some of the issues that the existing framework has versus just build on top of something that exists that's also beta tested? How do you make that decision internally?
Did it exist at the time? I'm not sure. Like in February, March.
Yes, I'm fairly sure it was.
Yeah, I'm not sure. I mean, I guess we had some algorithms in mind we wanted to start with. You know, it was also, I will mention that in the presentation, but at the beginning we were like not sure to go for LLHF, and we decided to move that later. We were like more like, at the beginning of the project, I was more, okay, look, we want ChatGPT as soon as possible. We have a lot of budget. maybe SFT is better. Maybe we should do LLHF as well because people are doing it. But I didn't have strong research conviction of why doing one or another one. I will go back actually to why I changed completely my mind with this project.
Awesome, thanks.
But so, yeah, to go there, that's basically the iterative improvement we had on two axes, helpfulness and harmlessness, according to our reward model, but also according to GPT-4. So you can see the progress. And I really like this slide because this figure with respect to GPT-4, here is the win rate of given a prompt that we had in the test set, the output of ChatGPT 3.5 versus our model, which one GPT-4 prefers. And we ended the latest model that we released to like 60 on harmlessness safety and almost 70% win rate on helpfulness, meaning that GPT-4 probably prefers our outputs. And so here is like another way to see it, like with the shift of distribution with respect to the reward models, where we started the project with some open source data set, then the SFT, and then LLHF. And you can see that, so here you have the reward model score. 0 means it's very bad, 1 is perfect. And you can see how the distribution, we flatten it on the left, which is basically the bad outputs according to the reward model, and we move it to the right. And so, yeah, one last example, very cool, that we saw as an emergence before I move to like some secret about the LLHF and that I was discussing why we changed our mind. So we figure out if you have as a system prompt, like what's the date today and what's the cutting knowledge date, you can play with that. And the model completely like structure its temporal perception and knowledge very well. Those are not like cherry pick example. I tested a lot and it works pretty well. So if you tell the model like you don't have any knowledge after the 40s, and you ask who won the Second World War, well, the model said, I don't know. In the same way, if you say like, if the flat or round and the year changes, like it's now, it will tell you about image satellites, GPS, etc. So it's obviously not flat. But if you tell the model you are in the year 852, tell you that actually at this time people believed it was flat. And honestly, this result surprised me a lot.
It's super interesting and also connected, I guess, to the theory of mind in a way. Like you can think of it as the model having like a perspective from that temporal dimension as opposed from somebody's perspective of like a human being or whatnot.
Yeah,
it's
totally.
like definitely related to that property, right?
Yep.
Behavior.
Absolutely, I fully agree. I think it's kind of connected. And so, yeah, here to this real magic I discovered for the project. So,
excuse me, just a question before you move to that.
Please.
How do you constrain model in that temporal dimension? Is it by system prompt, or were you doing experiments with actually like not feeding more recent text into it?
Oh no, it's just by system prompt. Like, see, for instance, the cutting knowledge. Actually, the model has information its ways. This is if you ask LLaMA 2 who won the Second World War, it should probably answer pretty well. That's like a very easy question for it. So it understood that when you put a cutting knowledge and you force it, it understands that it should answer it doesn't know. Those are good examples. You can you play with LLaMA 2 and the system prompt and put that, and it will work as that.
Thank you for clarifying.
So we had two ways to annotate, remember? Supervised fine-tuning. In the case, the annotator writes the prompt, but also the response. And human preference, where we sample from the models with respect to the prompt, and we just as a human which one he prefers. Like, honestly, human preference is 10 times cheaper, but asking a model to generate synthetic data is not always a good idea. And if you ask me a few months ago, I would totally say, if I have an infinite budget, I will go for supervised fine-tuning, which is a gold standard. Like good annotators, there's nothing better. I was completely wrong. And very early in the project, we ran a human evaluation, very interestingly, comparing the model output and what the human had as an SFT answer. And we figured out from this human evaluation that the model responses were better than what humans were generating. And actually, large language models are already and very easily, for a lot of tasks and more tasks, not all of them yet, getting better superhuman level performance for creative writing. And so let me give you an intuition of what I said and how is it related to LLHF. I give you this prompt, write a haiku about large language models. You know, haiku is like 3 lines poetry in Japanese. I will give you like 5-10 seconds to think about a good answer that you will have. If you are my annotator, what would you have written here?
I would go to Wikipedia to get some inspiration. So like rag, I would do some version of rag.
And I mean, so just the time it will take you to go to Wikipedia for this simple 3-line question. And I'm not sure, I mean, I don't know if you're good at that. I'm super bad. I will be a terrible annotator for this kind of creative prompts. This is in 1 second what our model generated. Honestly, it's better than most of what the human will have done and in a so short amount of time.
It's amazingly good, shockingly good. I would first have to look up the exact definition of haiku. Like I know roughly what it is, but like there are just so many components in there, right?
Yeah. And so the conclusion is, you know, model outputs are already superior than supervised annotation by human. And I think this actually has extraordinarily huge impact in terms of for the field, but not everyone has understood yet. We're in a new era, and human annotation is not the gold standard anymore for writing abilities, and for a lot of tasks and more. And so I think the secret of LLHF is not reinforcement learning, it's not human feedback. Actually, it's about how to combine the human and the LLM to annotate at a superhuman level. And this has tremendous impact because the thing is not about reinforcement learning or super cool algorithms. It's more about, in terms of research directions, how can we go even further? Maybe we could ask the LLMs to now help the humans to be more creative in their answers or to write the prompts in a more diverse way, more complexify the prompts, write some follow-up ideas, develop an LLM-based tool that will enable to annotate some super hard tasks in a combination to debug at fine-grained levels what the human will have done. And so I think it's much more about going to like this synergy of human and LLM to create data that was not even possible 6 months ago. So we can train a new generation of LLM on this new data than anything else, this LLHF secret sauce. So what will happen next? Well, I will take not a lot of time actually to discuss that. So we can spend some time for questions. But next 16 months will be about multimodal inputs, outputs. We're already seeing that with DALL-E 3 connected to ChatGPT, etc. I think this is mostly an engineering question now for a lot of those aspects. And that will be something done in a very short amount of time. And yet there's some like how to generate long, consistent videos. This is still a research question. Access to the web, connecting to tools. I mean, I'm a tool former author, and obviously that's a direction that matters a lot to me. So a Siri that works, basically. We have starting seeing that also with ChatGPT, with plugins. Just the beginnings, I feel like it's not working well yet. It hopefully will soon. And that just gives a new possibility for what we can do beyond the weight of the model, kind of a generalization of the non-parametrical way, where the model, you don't have to chat it in a closed environment, but now it has access to the world, can possibly take actions, which is the new level of possibilities. And the access to physical world. Well, what comes after digital world, the physical world? I think we will start to see the first iteration of that the next 16 months. It will definitely not be solved and will take probably a lot more of time. But I'm very curious to see when we'll connect those LLMs, and we had some papers starting doing that, to some robots, what can be possible in terms of embodiment in the real world. And yet, let me say that a new breakthrough is arguably expected. With this decade of AI research have taught us that every few years we'll have some new breakthrough that will put all the field upside down. So the unlikely is likely to happen, and I have no idea what it will be. And so the bitter lesson is that compute is maybe all we need. Is it? I don't know. But I can tell you that scale will keep giving some nice low-hanging fruit and some progress. Is it the only all we need to go to AGI? I have honestly no idea. It is clear that to me, these models are not just stochastic parrots. The fact that they can compress information in that beautiful way with shows some clear understanding beyond just the data of what is a clear algorithm underneath the data. But will it be enough for AGI? I don't know. If it's the case, and I will end the talk with that, maybe it will be a Copernicus moment for intelligence. Like after finding that Earth was nothing special with Copernicus, normal planet orbiting a normal star, a normal galaxy, maybe we will learn that intelligence too is nothing crazy, just a bunch of matrix multiplication. Thank you.
Thomas, this was amazing. Really, really amazing talk. I really enjoyed it. And like first question, if you can go back like slide or two where you were discussing the compute is all you need.
This?
I mean, one thought that pops onto mind there is like evolution only needed a good environment and a ton of scale, massively parallel, and like we ended up with these interesting artifacts that are now trying to recreate that same thing. Like I don't know, like it doesn't seem that like it definitely feels that Rich was very prescient with the bitter lesson. That's one comment, and then one question. You mentioned here robotics and multimodal. Like completely agree. I don't think you mentioned too much the synthetic data. You did mention a bit the generation, the augmentation of human generation, like when you're collecting the data for alignment. But like, how do you think about the grading part as well, like the RLAIF and similar efforts?
So maybe two things. Well, I'm not a big fan of the word RLAIF, because to me, if I go back to this slide, it's already RLAIF somehow. It's just a synergy between the human and the AI to create better data. So, and so far, if I'm correct, RLAIF is still leveraging humans to create the prompts of what we want and ingesting the data. So it's not like purely, it's not without humans somehow. Basically, it's already the case. Now, what I think about synthetic data to digest to the models, I think it will be the next trillion tokens.
Trillions and trillions, right?
yeah, trillions of trillions. I think, yeah, there's no, I mean, it's already the case somehow. What we do with this rejection sampling algorithm is sampling, asking our model to select the best, and fine-tuning on that. So somehow all the fine-tuning is based on synthetic data.
Interesting. Okay, we have questions raised. Ivan, you want to go ahead?
Yes, of course. I have 3 questions. Can I ask that much?
Sure.
So
maybe start with one, because we can do a round robin. There is a couple more people there.
Why didn't you go like something like switch transformer approach, which is a bit more compute efficient and like inference computer, both training compute and inference compute, but less parameter efficient?
I think there's a lot of research to be done in a more efficient models, better recipe. I don't have anything like smart to tell you or like some secret sauce to tell you for which one will be LLaMA free. Like transformer are good algorithms, that's probably better algorithms we could find. If it's the case, that will be interesting.
Thanks, Thomas. Michael is next.
Yeah, hi. I asked a question in the chat already. It's going direction. There is like RLHF, and it obviously made like this nice prompts and LLaMA, like nice visualizations in the paper and all these cool evaluations possible. There's recently also been work which like uses like reformulation of this loss basically, which uses like basically my question just to say first is why RLHF was like in decision. I mean, it was proposed by OpenAI some time ago because they use PPO like extensively for a lot of problems, and now everybody's just using it. But the question is, was there like a decision? Because also some other people showed, okay, this is just like some kind of contrastive loss problem, and this also worked quite well as a paper, direct preference optimization. Is it like RLHF the future in this direction? Will it be still reinforcement learning, or will it go like more to other formulations?
So I think the thing is, like, if I go to the slides, like here, well, I don't have all the data for to show you like data improvements, but I think what matters is not the algorithm itself. There's some research that could be done to optimize it a bit better, to make it more efficient, more simple. But it's not the RL that matters here. It's the way we created the data leveraging between the human and the machine. And so whatever is it, rejection sampling, then PPO, then DPO, as long as it works and it shifts the curves to what the reward model wants efficiently, it's good.
It's interesting how prescient Jan was years ago with cherry on top of the cake type of visual analogy. Like it literally looks like the recipe like for what we are doing right now. A quick comment on my side. RLHF was, I think, a collab between DeepMind and OpenAI. I think only one author was from OpenAI. And then connecting to that, like this looks suspiciously like what we had back in 2016 with AlphaGo series of models. Like everything started, okay, first we leverage just human data and we let the model train on top of that. And then we slowly start like removing the humans from the loop. Like more and more towards like self-play, and like I definitely see the same trend with LLMs. Like, and it's just going to be very compute intensive to obviously have something like a self-play with like huge LLMs. But like I do see a parallel there. Like if you have any thoughts on there.
I have the same kind of thoughts. I see the parallel. Yet I think the main difference is that for AlphaGo you know which one works, which one wins in good game of Go. You know which one, if your solution is correct for maybe a coding problem. You don't know if your output is good or not.
Well, if you have a good reward model that represents distilled community preference, like in that way, yeah, I mean.
No, absolutely. But then, and that's why I really insisted on this on one slide about how the reward model is critical, and just improving the reward model helps to improve. So it was there. The improve basically whatever your recipe. If you improve the reward model, you will improve everything. And indeed, I agree with you. If you have a perfect reward model with 100% and no way to hack it, then you could apply the kind of analogy you had with the game of Go and self-play. But then it's an open research question. If you could get this perfect reward model, I'm not sure it is even possible.
Yeah, I mean, I agree. First of all, it's like culture dependent, right? A lot of those details. Maybe we can all agree like along some of the main ethical dimensions, like don't kill your fellow human being or something like that. But like all of the subtle things are going to be definitely culture dependent. So yeah, it's different when you have these closed game systems like chess or whatnot. Maybe related to this whole RL story, like I just briefly saw this morning or yesterday even, like there is this tweets kind of circulating with the Q star or something. Like, what's that about? I didn't get the time to read through. Is it just like some of the older RL techniques being like I don't know, hyped up from people who don't know how it works, or what?
I saw it. I don't have thoughts yet. I really don't know if it's something big, something not big, what it is exactly. And so far, it's more rumors than anything else.
Yeah, sounds good. Okay, Zach is next, and we can slowly wrap it up, and then Daniil.
Yeah, thanks. Really great talk. My question was kind of going off what was just said. Basically, we know that even humans aren't the best annotators, and so I guess one solution to that is just to scale things up and maybe average out across multiple people. But like I've heard of reward hacking cases where longer responses are always preferred, so that could be a bias that's being baked into the model. And so is it better just to, like kind of as Aleksa was saying, just switch to a fully automated AI annotated approach, provided you actually spend the time to really make sure that model is less biased than the average person?
Yeah, that's a good question. But so I think it's not clear to me if annotators are biased with respect to longer answer because they are just biased, or if it's not because, so an algorithmic problem, like in longer answer, you have more information and more content. And so in general, it's better to have some longer answer. But then there's a lot of cases where it's not true. And so I think it's more like a kind of a reward hacking problem where we don't have the data corresponding to some short answer and the model is not able to learn that in some prompts you want longer answer because you want more context, but in some others you don't want that, and to distinguish a bit. And I suspect it might be something related to that, which in that case, my answer will be just collect more data where you incentivize actually shorter answer, and maybe the model will learn.
Maybe we're still in the period where we're trying to bootstrap these models, and then at one point, that's the AlphaGo analogy I mentioned. Kind of, we just remove the human from the loop. But like, yeah, hopefully we'll need the humans around.
Yeah, but what to echo on that, I mean, but the way I think we should remove the human in the loop, but that's what I think is interesting in my answer here is my intuition is we should not remove them trying to fix something that we identified, because there are actually hundreds of other things hidden. Is more so the way we should fix it is something that we can scale, betting that the method we apply will not fix only that, but the 100 things that are hidden, and not just this problem that is the surface of the iceberg.
Yeah, and ultimately we are aligning these systems to humans, so it's going to be a bit different situation, like unless we create a god. Danilo, you have the last question, and then we can offload the last ones. Even maybe you can ask in Discord the latter questions. Danilo,
hello everyone. I hope that you can hear me.
Yes.
As of my knowledge, LLMs are trained on some data on which they are limited when it comes to generation, right?
Say again?
As of my knowledge, large language models are trained on some data on which they are limited when it comes to generation. So my question is, what do you think about a model that would use inference to retrain itself constantly while gathering new data?
So I think it's a closed loop and it will not work. But I think augmented, for instance, with tools, it will kind of punch above its weight, and then maybe something can happen.
super intelligence hints.
Yeah, you need basically to incorporate additional information to the generation rather than just the model itself to not be in the closed loop.
Awesome.
When I say gathering the new data, I was thinking about some sensors for picking up, I don't know, speech or videos or something like that. So I don't think of it as a closed loop, like a model retraining itself on itself, but on the new data that it is gathering through videos or sound.
Oh yeah, in that sense, I mean, yeah, obviously you applying Whisper to like some audio to get new data that you didn't have for the previous model. That makes a lot of sense.
Yeah, or NuGet for PDFs, etc., etc. It's obvious everybody's doing. Everybody's collecting new tokens from multiple modalities. Like video is the next frontier, I guess, and that's why people are pushing VLMs. It's just so interesting how much all these components contribute to each other. It's just
yeah, I absolutely agree. Yeah, that's fascinating.
Yeah. Awesome. Thomas, thanks a lot for coming. I think this was one of the most interesting talks, in my opinion, for me at least, over the last period. So like, really appreciate you coming. And with that, I'm going to stop recording.
Well, thank you for having me. Thanks, everyone.